Hey Varsity Chemists, welcome to our channel.
Today we'll be discussing Coulombs law.
Hey Molly.
What's up?
What's the difference between an ohm and a coulomb?
What?
Boom! Photo! Now, let's get down to business.
Coulombs law is a law stating that charges repel and opposites attract, with a force proportional to the product of the charges and inversely proportional to the square of the distance between them.
Well, that made absolutely no sense, but by the end of this video, it'll all be clear.
Wait, it'll all make sense at the whiteboard.
Alright, let's break down Molly's definition of Coulomb's law. It starts with like charges are going to repel and opposite charges are going to attract. Now here, Molly has drawn a carbon atom. Carbon has an atomic number of 6. That means that there are 6 protons, 6 neutrons, and 6 electrons. The protons are in the nucleus along with the neutrons, and the electrons are surrounding the nucleus. The neutrons are in the center because why?
Like charges repel and opposites attract, and without any neutrons in the nucleus, it would not be stable.
When the nucleus is stable, the protons can then attract the surrounding electrons.
Now, the second part of the definition is with a force proportional to the product of the charges and inversely proportional to the square of the distance between them.
Well, that makes absolutely no sense either. Let's go back to the drawing board. All right, let's make sense of all those words. It all makes sense in an equation. The equation for Coulomb's law is F equals K times Q1 times Q2 all over R squared. F equals the force of Coulomb's law. K is a constant. The constant number is 9.0 times 10 to the 9th. Q1 is the quantity of charge in object 1. Q2 is the quantity of charge in object 2. And R is the distance between the two objects.
So basically, my definition.
Yeah, but mine made it more simple. Plug and chug, and voila, you have your Coulombic force. So let's think about this.
Logically. So what you're saying is, as the objects get closer, the charges get larger?
Essentially, yes. Let's look at a diagram. So here, we have two objects, and here is the distance between them. So if this number gets smaller, you can see here, when it's divided by, the force will get bigger. Does that make sense?
Yes. Can you give me an example?
Of course. So here, if you take 10 and divide it by 5, you're going to get 2. But if you take 10 and make this number smaller, you're going to get 5. Therefore, when the radius is a smaller number, you're going to get a bigger force. So here's a practice problem. You're going to be given all of these values, and all you have to do is plug it in and solve for F. Here's the constant, K, multiplied by Q1 and Q2, which happen to be the same number, and divide all of this by R, and don't forget to square it.
So now that I've plugged it all in, the answer is 9.23 times 10 to the negative 7th coulombs. Now remember, sig figs. Thanks for watching.
I hope you learned all about Coulomb's law.
And how to calculate the force of attraction.
Just remember, a coulomb is much better than a regular ohm.
We hope to see you on our next video that we discuss
Electronegativity. Thanks for watching.